Hello everyone, welcome to Solve Search classes. This is Tushar Shaw, and in this video we will be continuing to solve the PUMDET latest year question paper. Okay. Uh, okay. So in the last video we did up till question number 41. Okay. So in this video we will be starting from question number 42. Let us start by that. The question says that the solubility in grams of potassium hydrogen tartarate in water and in so we are taking potassium hydrogen tartrate. Okay, KHTA. We are dissolving this in. Firstly, we are dissolving it in water. Then we are dissolving it in 0.1 molar KCl, and obviously this is an aqueous medium, that is water, and then we are dissolving it in 0.1 molar KOH solution, which is aqueous. Okay. So the question asks that the solubility for these three are given to be this one to be as S0, this one to be as S1, and this one to be as S2. Okay. So respectively, obviously. So the order of solubility uh, is okay. So the question requires that we write the order of solubility of KHTA, that is for sodium potassium hydrogen tartarate in water, and these two solutions. So the solubility is measured by the amount of salt required to saturate 100 ml of solution. Okay. So we are taking the amount of salt taken, salt, that is the KHTA taken, to dissolve it in 100 ml of water, 100 ml of 0.1 molar KCl solution, and 100 ml of 0.1 molar KOH solution. Okay. So obviously, as a competing electrolyte, KCl and KOH, the solubility of KHTA and KCl and KOH would be extremely less and as compared to water. Okay, why this is so? Because water in aqua solution containing KCl would be having already an electrolyte, and therefore that is also dissolved in that water, that aqua solution, and after that KHTA is being added. Okay, so obviously because of the presence of KCl, the amount that will be dissolved in the amount of KHTA that will be dissolved in this aqua solution would be less. Okay, so in this case we get that the solubility of KHTA in water would be the highest. Okay, after that there will be S1 or S2 that we'll be solving, but in the options you can see that option, except for option B. Okay, so except for option B, none of the options have S0 as the highest solubility state. Okay, none of them. Each one of them has either S2 or maximum of them has S2 as the major solubility. After that there is S1, but only option B has this order that is given: S1 is greater than S0 is greater than S1, greater than S2. To some extent this order is correct. Okay, we don't know the values about S1 and S2, but that is not our concern over here. We just got the answer by the first option only. Okay, so option B here is the correct option. Moving on to the next question. Um, so the next question says, that is question number 43. It says that the colored solution of a dye with concentration C1, okay, C1 concentration is given, absorbs a wavelength lambda and at temperature T with the transmittance of 7%. Okay, so the transmittance here is 7%. Okay, so if we calculate the absorbance over here, so absorbance is equal to 2 minus log T, sorry, 2 minus log T when T is in percentage form. Okay, so 2 minus log of 7, which is equal to let me just calculate, uh, 2 minus log 7, which comes to be 1.1549. Okay, so this is the absorbance for the first solution. Okay, now from this we can calculate the concentration of the initial solution. Now we know that absorbance is equal to epsilon Cl. Okay, where epsilon is the molar extinction coefficient, C is the concentration of the solution, and L is the tube length. Okay, that we have taken in the spectrophotometer. Okay, so let me just write these down. Molar extinction coefficient. This one is concentration of the solution, and the length of the tube taken in the spectrophotometer. Okay, so by this formula we can calculate the value of C1, that for the first solution. For the first solution we got absorbance is equal to 1.1549. Okay, is equal to C1, we will be writing it like that as it is. Okay, and the value of epsilon into L. So in the question the value of epsilon into L is given to be 1 liter per mole. Okay, 1.0 liter per mole. So this will be equal to into 1.0 liter per mole. So therefore C1 would be calculated here to be 1549 moles per liter. So this one was the calculation of C1. Now it says that we have to calculate the value of C2 minus C1. Okay, so another situation is given where it absorbs 30%. So the absorbance firstly is given to be 30%. Okay, so absorbance is 30. I'm sorry, the light absorbs 30%. Okay, so from here the transmittance would be 70%. Okay, light transmitted would be 70%. That is the transmittance. So therefore we can calculate the absorbance as 2 minus log T, which is equal to 2 minus log of 70%. 70 is equal to, let me just calculate the value, uh, 2 minus log 70, which comes to be 0.1549. Okay, 0. The pointer, yeah, 0.1549. Okay, so this is the case. Now again from the equation A is equal to epsilon CL, we will be calculate here the C2 would be given, and epsilon into L value is still equal to 1 liter per mole. Okay, so from here we get the absorbance value, we put it here 1.54, 1.1549, 0.1549 is equal to C2 into 1.0 liter per mole, or hence C2 would be equal to 0.1549 moles per liter. So when we calculate the difference C1 minus C2, it is found out to be uh, so we have C1 minus C2 would be equal to 1.1549 moles per liter minus 0.1549 moles per liter. This would be equal to 1 mole per liter. Okay. Obviously, the value that we need to calculate is C2 minus C1. Okay. C2 minus C1. So here would be a minus here. And the answers you can see that one option A is there. Okay, in the option A the option 1 is given. We can neglect the minus because we are just taking the difference between the C2 and the C1. Okay, so option A here would be the correct answer, that is having 1.0 mole as the option. Okay, so let's move on to the next question, that is question number 45. Okay, so it says that for a simple harmonic oscillator, that is in SHO, in a one dimension, the 0 point energy is m times the energy gap between the successive levels. Okay, so the value of m is, for the simple harmonic oscillator, we have the formula for the 0 point energy is given to be 0 point energy E naught is given is written as half h nu. Okay, here nu is the frequency of the energy, and h is the Planck's constant. H is Planck's constant. Nu is frequency. In the question, it is given to be m times the energy gap between the successive levels. Now, the for the formula for energy gap, successive energy gap levels is n plus half h nu. Okay, n plus half into h nu. Now what happens is, for between each successive level, let us say we have a gap of 1. Okay, so 1 h nu would be the gap of one energy level. Okay, let us say from the energy 1 to 2. Okay, what would be having is, the gap of h nu would be released, the transition energy would be h nu. Okay, so the h nu would be the gap of the energy difference between two successive levels, and m is the number that is being multiplied in the question. Okay, so m here is half, which is equal to zero point 0.5. Okay, so in the options you can see that option C has 0.5 as their answer, so option C would be correct one. Okay, yeah, moving on to the next question. That is question number 46. Okay, um this question is a kind of tricky one. It says that two optically active substances, A and B, are mixed, taking 5 gram of each, and the mixture was dissolved in 100 ml of water. Okay, so the concentration here is 5 gram per liter, 5 gram per 100 ml. I'm sorry, 0.05 gram per ml is the concentration, like the no, not the concentration term, in the weight by volume term, W by V. 0.05 gram of both the A and B are taken. A and B are taken. Okay. The specific rotation of A is equal to plus 50 degree, and specific rotation of B is equal to minus 110 degree. Okay, respectively. The mixture is placed in 2 decimeter polarimeter tube. Okay, so the length of the tube is 2 decimeter. Okay, 2 decimeter. Okay, and the optical rotation is noted. The value of the value will be, okay, so the value of optical rotation of this solution containing 0.05 gram per ml of both A and B in the solution. The specific rotation of both the samples are provided to us. Okay, now both of them would be, as both of them are in equal amount of solute is given, both of them would be having the equal concentration. Okay, and for equal concentration, this minus 0.01 degree would be deflecting more than the plus 50 degree. Okay, we already know that the formula specific rotation is equal to 100 into alpha divided by, which is the rotation of that sample, into c divided by c into L. Okay, but in this case, this formula like it is not like it is not required to use this formula, because we can just calculate the we can just find out the formula just by looking at the sum. Okay, the sum is the formula is given in the question. The answer, I'm sorry, the answer is given in the question. It says that for equal concentration, where the specific rotation of B is higher than the A. Okay, so if we mix equal concentration of that in a same solution, what would we having is this, the B would be deflecting the polarimeter more to the negative side than A in the positive side. Okay, so at the end, like the solution therefore would be giving overall, as the specific rotation to be, the rotation of the polarimeter to be in the minus direction, that is in the minus side. Okay, so obviously in the options you can see that option B just has minus 6 as the answer, 6 degree as the answer, and that would be the correct option. Okay, because that one is the only one has showing minus 6 as the like the minus symbol rotation as the correct one. Okay, now you might be thinking, why not 0? The plus one is still understood. The value of rotation for plus one is less, so we do not, the value is compensated. Okay, but why not 0? So 0 would be 0 if the specific rotation of the mixture is 0, then the for the a racemic mixture would have been formed. Okay, now for a racemic mixture to form, both of them must have the equal concentration and equal rotations on the opposite sides. They have the equal rotation but not the equal they have the equal concentration but not the equal rotation on both the sides. As the negative one is higher, we would be getting the value of negative one to be much greater. Okay, So let us wrap this video up. We did quite a lot of questions in this video. Probably in next 2 or 3 videos, we'll be completing the PUMDET set of questions, and then we'll be moving on to GATE 2021 questions. Okay. So thank you guys for this video. I'll see you guys in the next one.